Okay, in this session I'm going to do a couple of practice problems from section 1 from section 4.3 and one from section 4.4 of our pre-calculus textbook. The first one is page 154, number 40. If you want to get the most out of this, I would say pause the recording now, try to work the problem yourself, and then watch the recording to see how you did. So this problem says, suppose Y is the number of cases of the disease and it is reduced by 10% per year. Part A says if there are 10,000 cases initially, write a formula for Y as a function of the years t. So in our case, Y is A times B to the t. It's exponential because it's a constant percent change. It's reduced by 10% a year. In our case, the A is 10,000 because the A in an exponential function is the initial amount. The R, the B is 1 plus R, and the R in our case is minus 0.10. Because it's reduced by 10%, so the R is the decimal representation of the percent change, so it's minus 0.10. So the B is 1 minus 0.10, which is 0.90. So our formula is Y equals 10,000 times 0.9 to the t. That's the answer to part A. Okay. Part B says, how many cases will there be 5 years from now? Basically, they're asking if t equals 5, y equals what? Well, if t equals 5, y equals 10,000 times 0.9 to the 5th power. And if you plug that in your calculator, you will see that it is 5,904.9. Since it's number of cases, you probably would round to the nearest value, so you would say it's probably 5,905 cases. We'll leave it like that. See, it says, how long until you get to 1,000 cases? So they're saying Y is 1,000, T is what? So you have this formula, 1,000 equals 10,000 times 0.9 to the t power. You can just start plugging in values and seeing what you get, but really if you look at this, if you divide both sides by 10,000, it's the same as 0.1 equals 0.9 to the t. So if you start plugging in values, you'll see that you'll get different things. So 0.9 to the 20th power, I'm sorry, to the 21st power is 0.1094. 0.9 to the 22nd power is 0.09848. You want to see what t you need to get 0.1, so you're trying to figure it out. You see that if you plug in 21, you get more than 0.1. If you plug in 22, you get less than 0.1, so it must be between 22 and 21. If you check keep trying to narrow it down. 0.9 to the 21.854 is approximately 0.1. So we'll say it's t equals 21.854. Or somewhere between 21 years and 22 years. Almost close to 22 years is how long it takes. Okay, the next problem that I'm going to work through is page 158, number 22. In this problem, we're still looking at our b equals p 1 plus r over n to the nt, where p is the principal, initial amount invested, r is the decimal representation of the percent change, n is the number of compounds per year, and t is the number of years, and b is your balance. So on these problems, it actually gives us several formulas. It says, without making any calculations, briefly describe in words what the following formulas tell you about the value of the investments. So the first one, the value, instead of b, instead of balance, they're going to call it value, is 1,500, 1.077 to the t. If we compare that to our b equals p 1 plus r over n to the nt formula, we will see that the p, or the amount you originally invested, was $1,500. You'll see that the n is 1. You'll see that the r is 1.077 minus 1, which is 0.077. So the interest rate is 7.7%. So what this formula says is that you invested $1,500 at a 7.7% interest rate, compounded yearly. Okay, part B, it gives us the value is 9,500 times 0.945 to the t. On this one, we can see the P is 9,500, the R is 0.945 minus 1, which is minus 0.055, or minus 5.5%, and the N is 1. So you could say you invested $9,500 at a 5.5% annual loss. So every year you lose 5.5% of your investments. You know, it's possible this could actually be something like real life, like a car loses value over time, right? So it's not a good investment to make money off of. Part C, our value is 1,000 times 3 to the t divided by 5. So we need to convert this to look like our formula, so it should look like 1,000. And we could actually rewrite this as the 5th root of 3 to the t power, which is actually 1,000 times 1.2457 to the t power. So you have a p of 1,000, an n of 1 again, an r of 1.2457 minus 1, or 0.2457. So it's a 24.57% interest rate. So basically you could say this is invest $1,000 at 25.5% interest compounded yearly. The last one, the value is 500. 1 plus 0.04 divided by 12 to the 12p. In this one you see the p is 500, the n is 12, and the r is 0.04 or 4%. So this one is you invest $500 at a 4% interest compounded monthly. Okay, hopefully those two problems helped you, and if not, you can ask more questions on Monday.